Okay, question 2 of the 2023 AP Calculus BC exam, the free response questions. Again, this is the calculator portion, so have your graphing calculator with you as we go through these questions. And we've got a parametric motion question. And in the question it reads, for t being some value between 0 and pi inclusive, a particle is moving along the curve shown so that its position at time t is x of t, y of t, where x of t is not explicitly given, but y of t is, it is 2 sine t. It is known that dx dt is equal to e to the cosine of t power. And at time t equals 0, the particle is at position 1, 0. Okay, so we got some information here. And take a moment, maybe pause the video, read through it one more time. I always like to do that when these free response questions, underline whatever you need to. But let's start with part A. It says, find the acceleration vector of the particle at time t is equal to 1. Well, for this, we should recognize that the acceleration, we're going to need the derivative of dx dt and the derivative of dy dt. So that is to say, first off, we don't know what x is, but we do know that dx dt is given. So first things first, we need to find the derivative of y of t. So let's start with that. So we're going to say that dy dt is simply the derivative of the function y that is given here, and that's pretty straightforward. This is just going to be equal to 2 cosine of t, okay? And a of t is going to be equal to, again, and we're going to write this in vector notation, x double prime of t, or the second derivative of x, and y double prime of t. Remember that the acceleration is the derivative of velocity, or the rate at which velocity is changing. So since velocity is the first derivative, we're going to need the second derivative here. So from that, we're going to take a of 1 being equal to, all right, so we need the second derivative of dx dt evaluated at 1. So what you can just do is, in your calculator, find the derivative of this function here evaluated at 1. And when you do that, you should get negative 1.444, okay? And that's if you are, actually regardless of whether or not you're rounding or truncating, you should get that. And then you're going to need to find the second derivative of y. Again, now that we know what dy dt is, we found that over here. Dy dt is equal to 2 cosine t. Since we know that, take the derivative of that function, again, evaluated at 1, and you should get negative 1.682. So there's not too much in terms of work, but it's mostly pre-calculator heavy. And if you actually wanted to truncate instead of round, you could have also said negative 1.683, okay? All right, so in terms of the work for the setup, this is all that was really required for the work, okay? All right, so let's look at the next part. It says, now, part B, from 0 to pi, find the first time t at which the speed of the particle is 1.5. Show the work that leads to your answer. Well, we should remember that speed is equal to the absolute value of our velocity function. And hopefully you're familiar with the following formula. We would just say dx dt squared plus dy dt squared, okay? And what we're trying to do is we're trying to see where the speed is equal to 1.5. Find the first value of t such that this is equal to 1.5. So what you're going to need to do in your calculator is you're going to want to graph the following in your calculator. We're going to enter in an equation into our calculator. We're going to say y is equal to dx dt squared plus dy dt squared minus 1.5. And from this, we're going to want to find the first zero. Find the first zero where this occurs. Okay, so we're going to want to find the first zero there. And so in your calculator, there really isn't that much to this. If you keep in mind that we already know what dx dt is. We found that is given to us. Dx dt is given to us right over here. We found dy dt from our previous step. So we're just going to square each of those functions, take the square root of it, minus 1.5. And you don't have to graph this in your free response, but I just wanted to give you a sense that that graph is going to look probably not that linear. it's going to look something like this. And what you're trying to do is you're finding this particular zero, and it turns out that t is equal to, or approximately equal to, 1.254 seconds. And that's the first time where it hits the x-axis. So that's going to be our value, right? And I'm going to write the first time, okay? So really it's just pretty calculator heavy again for this part. All right, moving on to part C. Find the slope of the tangent line to the path of the particle at time t is equal to 1. Find the x-coordinate of the position of the particle at this time. Show the work that leads to your answers. Well, slope, we can say slope is equal to our dy dx, and we're going to evaluate this function, or dy dx, at t is equal to 1. So to find dy dx, we're going to need dy dt over dx dt. And we can say that that is equal to, we know what dy dt is, again, that's given, 2 cosine of t, or excuse me, dy dt was not given, we figured that out in part A, but dy dt evaluated at 1 is what we want to put in there. And then, actually, you know what, let me actually write this with t, and then we'll show that we're evaluating it at 1. And then dx dt is going to be e to the cosine of t, that is given. And so we can say dy dx, and actually, you know what, let me try not to get this too mixed up. So, you know what, I'll just do this. Got to be very careful about what we communicate here. So we know that, I don't want all of the problem. All right, so dy dx is equal to that, so we got that there. So now we can find dy dx evaluated at t is equal to 1, which is going to be 2 cosine of 1 over e to the cosine of 1 power. Punch that into your calculator, and you should get 0.629 if you are truncating, or 0.630 if you are a rounder. Now in the part of this, find the x-coordinate. We then needed to find the x-coordinate of the position of the particle at time t is equal to 1. So from here, we're going to just say x of 1 is equal to start plus accumulation. 1, which is where it started, integral from 0 to 1 of e to the cosine t dt, and this is going to come out to 3.341 or 3.342, again, depending on whether or not you round or truncate. All right, now let's go on to the last part. Find the total distance traveled by the particle over the interval from 0 to pi, and we're going to show the setup as well. Well, total distance, this is simply going to be our arc length, or the distance traveled by the particle, which can be found by the arc length formula, which would be from 0 to pi. And we're going to take the square root of dx dt squared plus dy dt squared. I'm going to extend that radical. And don't forget that we're integrating this with respect to t. And after you put that into your calculator, you should get 6.034 or 6.035. All right, and that was the second question of the Calc BC exam for 2023 using a calculator.